Hi, good day. So I'll be explaining the answers and solutions for this problem. This is a topic on our subject transmission media and antenna systems under antenna. So this is the question. An antenna used for transmitting of has a power gain of 20, derivative gain of 22, and an input power of 200 watts. So we should be determining each and every one of this one by one. So first one would be the EIRP, or which stands for effective isotropic radiated power in watts, dBm, and dBW. So first is EIRP is equal to input power multiplied by power gain. So on our question, the two are given, which is we have the input power of 200 watts and the power gain of 20. So we multiply 200 by 20, we will have the EIRP as 4,000 watts. Next is we will be converting the value of EIRP to dBm, which we have this formula. We must multiply 10 logarithmic or 10 log EIRP over 0.001. So on our solution, we will substitute EIRP as we have 4,000 to this one. So 10 log 4,000 over 0.001. So the value of EIRP in dBm is equal to 66.0206 dBm. And next would be the value of EIRP in dBW, which we will be having by this formula 10 log EIRP over 1. So we'll just substitute it again. 10 log 4,000 over 1, which we will have the value of EIRP in dBW is equal to 36.0206 dBW. So on our next problem, we will be needing power density at a distance of 5 km from the antenna along the direction of maximum radiation. So for the power density, the unit of that is watts per meter square. So since the given is 5 kilometers, we will be needing to convert it to meters. So this is the conversion. For every 1 kilometers kilometer, there is 1,000 meters. So we will just multiply 5 kilometers to 1,000 meters over 1 kilometer, which we will get 5,000 meters. So for the power density is equal to EIRP over 4 pi times r squared. So we have the r squared as 5,000 meters. So we'll just substitute 4,000 over 4 pi times 5,000 squared, and we will have the power density as 12.7323 times 10 raised to 6 watts per meter square. So for the next one is the antenna efficiency. We will have this formula, which is power gain is equal to directive gain times the antenna efficiency. So to get the antenna efficiency, we'll be needing the power gain over the directive gain, which is 20 over 22. To have the formula, the percentage, we have to multiply it by 100. So we have the antenna efficiency as 90.9091%. Next, we'll be needing to have the radiated power from an antenna. So we will be using this formula. The antenna efficiency is equal to the radiated power over input power. So to get the radiated power, we will need to multiply input power to antenna efficiency, which will be 0.909091 times 200. So the radiated power from an antenna is 181.8182 watts. Next would be the radiation resistance and antenna effective resistance if current at feed point is 2 amperes. So we will be using this formula. Um, Radiated power is equal to free feed point current times a radiation resistance. So to get the radiation resistance, we need P rad over the um, feed point current, which is 181.8182 over 2 squared. So we will we have the value for radiation resistance is equal to 45.4546 ohms. Hi, this is another question that we'll be solving in our subject of transmission media and antenna system under the topic of antenna. So this is the question. An antenna has a radiation resistance of 80 ohms, effective resistance of 10 ohms, and directive gain of 30, and input power of 50 watts. So we will be determining the six following one by one. So for the first one is the antenna efficiency. We will be using this formula. Antenna efficiency is equal to radiation resistance over RR plus RO, which is the effective resistance, multiplied by 100. So we'll just substitute the values here, 80 over 80 plus 10 multiplied by 1000. So we have the antenna efficiency as 88.8889%. So next question would be antenna power gain in ratio and in dB. So we have this formula. Power gain is equal to directive gain multiplied by the efficiency. So we have in the given directive gain of 30 multiplied by 88.8889%, which we will have antenna power gain as 26.6667. And then we will be needing to get it in dB. So the solution would be 10 log multiplied AD, which is the directive gain times efficiency. So let's just substitute 10 log 30 times 0.88889. So we will have the value of power gain in dB as 14.2597 dB. Next is the radiated power in watts, dBm, and dBW. So for watts, we will be using this formula. Efficiency is equal to radiated power over input power. So to get the radiated power, we just need input power multiplied by efficiency. Just substitute for the input power 50 watts times 0.8889. We will have the power radiated power is equal to 44.4445 watts. So next is we need the PRAD and dBm. So the formula is equal to 10 log PRAD over 6 0.001. Let's just substitute it. 10 log 44.4445 over 0.001. So we have the value of P rad in dBm, which is 46.4782 dBm. Next would be the value of P rad in dBW. So the formula is 10 log P rad over 1. Let's just substitute 10 log 44.4445 over 1, which we will have the value of radiated power in dBW as 16.4782 dBW. Next is the EIRP, or again, effective isotropic radiated power in watts, dBm, and dBW. So for the EIRP, we have power, radiated power multiplied by power gain. So 44.4445 multiplied by 26.6667. So the EIRP value is 1185.1881 watts. Next is the EIRP value in dBm, which is we will have the formula 10 log EIRP over 0.001. Then just substitute 10 log 1185.1881 over 0.001. We will have the EIRP value dBm as 60.7379 dBm. Next is the value of EIRP as dBW, which we will use this formula 10 log EIRP over 1. Just substitute 10 log 1185.1881 over 1. We will have the value of EIRP in dBW as 30.7379. Next would be the power density 3 kilometers away from the antenna in the direction of maximum radiation. So since the value or the unit of power density is equal to watts per meter square, we will be needing to convert 3 kilometers to meters. Just multiply 3 kilometers by 1,000 meters over 1 kilometer, we will have 3,000 meters. So for the power density, we'll be using this formula, input power multiplied by power gain over 4 pi r squared. So the r is equal to the 3,000 meters. So just substitute it, 50 times 26.6667 over 4 pi 3,000 squared. So we'll be having power density as 11.7893 times 10 raised to negative 6 watts per meter square. And next would be the antenna current, which will be using this formula. P rad is equal to IF squared, which is feed point current, multiplied by radiation resistance. So to get the feed point current, will be having P rad over RR, which is 44.4445 over 80. So we'll be having this answer 0.5555. Since feed point current is squared, we'll need to get the square root of 0.5555, which is the value would be 0.7453 amperes, or we could get the milliamperes as 745.3565 milliamperes. That's all. Thank you.